That's all it's gonna go that way?
Yeah, that's how it was with the thing. That's how that whole thing got caught. Yeah. Ding. And then the gasoline's gonna be put up there.
Where's the gasoline gonna put right there?
Good morning. My name is Daniel, and we are doing the Rube Goldberg experiment.
My name's Zachary. So what's gonna happen is Daniel's gonna hit the golf ball. It's gonna hit the wood. This is going to be on fire. This is going to like that, which is going to like the string, which is going to make the ladder fall, which is going to hit the wood and the baking soda into the vinegar, and that's going to cause the chemical reaction that we're looking for. Okay, let's begin.
There is the chemical reaction. Thank you for scoping out our project. It took very hard work, and it was first try.
Yes, first try.
Yes. Thank you. My name is Daniel, and I'm here today to teach you guys how to balance out an equation. So quickly, let's get started. First thing you want to do is you want to see all your elements on one side, and you want to name them out. You got zinc, hydrogen, and chlorine. Now all these elements are very important into balancing out this equation. Now let's start numbering the elements. Zinc does not have a number near it, so we're just going to put a 1. Hydrogen does not have a number near it, so we're just going to put a 1. And chlorine does not have a number near it, so we're just going to put a 1. And we're going to do the same thing as this side as well. We're going to put zinc, hydrogen, and chlorine. Now zinc does not have a number around it, so we're just going to put a 1. Chlorine has 2, so we're going to have to put 2 right here, and hydrogen has 2 as well. Okay, so this is where you want to balance it out. Since this side has all 1s and this side has 2 2s and a 1, you want to get 2 of these elements right here so they can even out. And what you're going to want to do is, you cannot just put a 2 right here and just make that a 2. You're not allowed to do that. But what you can do is, you can stick a number 2 right here, and that will multiply the hydrogen, kind of like distributing, and the chlorine. And so what you do is change that to a 2, and change chlorine to a 2, and that is how you solve and balance an equation.
Okay, we're going to be solving this problem. Let's get started. If 5.0 grams of ClO to the third is decomposed, what volume of O2 is produced at STP? Okay, so first of all, K stands for potassium, Cl stands for chlorine, and O stands for oxygen. Okay, so in order to start this problem, we put 5.0 grams of KClO to the third, and then we multiply that by 1 mole of CClO to the third. And then we divide that by 122.5 ClO to the third. And the reason where I got this number from is from the atomic mass of the periodic table. K has a total of 39 atomic mass, and Cl has a total atomic mass of 35. And oxygen has a total atomic mass of 16. So then we add all those up together, and we have to multiply this by 3 because oxygen to the third. So we add all these up together, and that comes out to 122.5. And then we multiply that to 3 moles of oxygen to the second. And then at the bottom, 2 moles of KClO to the 3. And the reason why we put one on top, one on bottom is so they could cancel out at the very end. And then we multiply that by 22.4 liters of oxygen to the second. And where I got 22.4 liters from is that is the given formula that it comes with. And then we divide that by 1 mole of O2. Okay, so this cancels out, this cancels out, this cancels out, this cancels out, and finally, this cancels out. So now what we do, the last step, we multiply 5.0 times 1 times 3 times 22.4. So times 1 times 3 times 22.4. And then we have to divide this by 122.5, which was all the given atomic masses added up together. And then we times that by 2. Then we times that by 1. And that will come out to 336 for this part liters of oxygen to the second, which is what we're trying to find there. We're trying to find the volume. Then we divide that by 245, which is, doesn't look like a 4, 45, which is what that came out to. So there. And then we divide 336 by 245, and that comes out to 137. So that 1.37 is the volume.